worksheets that we looked at last time. I'll just go through kind of an example of each, one question from each one, and then we'll go into the new stuff. Okay, so first thing we looked at last time was rounding.
Yes.
We looked at two different ways to round. One of them was rounding to decimal places, and the other one was to significant figures.
Yes.
So let's take an example here. We're going to take 2.135.
Yes.
And let's start by trying to round that to two decimal places.
So we have to look at the 5, and if it's 5 or over, we're going to round up, and if it's 4 or down, we round down. So that one will be 2.414.
Yes, perfect. So this one here, exactly as you said, the 5 tells us to round up, so we now round the 2.13 becomes 2.14. Perfect.
Yes.
Okay, so how many significant figures have we rounded to in this example?
Two significant figures.
So let's count in the first number, not quite, so let's count from the first number. What digit in 2.135, what's the first significant figure? Which digit?
1.
No, 1.
Second, 2, 2, 2.
2, perfect. So the first significant figure is going to be this 2 here. So remember that the significant figures is the first non-zero.
Okay.
So when we think of decimal places, we're kind of fixing where we have to round. Okay, so for example, if I said round any number to one decimal place, it's always going to be the same place.
Yeah.
But with a significant figure, we can be a little bit more flexible in our rounding. So if I said to round to one significant figure, it's not always going to be in the same place. So for example, if I round these two numbers, so 2.135 and 325 to one significant figure, I can round both of them. So the first one would be on the 2, the second one would be on the 3.
Yes.
But if I was to round to one decimal place, they would have to round on the same place value. So this one will round here, and that one rounds here.
Yeah.
Okay? So that's kind of why we have those significant figures in the first place.
Yes.
Okay, perfect. So let's have a think about, so we've got our first significant figure in 2.135. Our first significant figure is the 2. What's the second?
The 1.
1, perfect. So 3 is
The third.
so this number here is rounded to 3 significant figures.
Yeah.
So here we've rounded it to 3 significant figures or 2 decimal places. Can we round something to one decimal place? Can you think of an example when we would round something to one decimal place and one significant figure at the same? When does that might give that?
So when the fourth, when the third, the second significant figure is a 50 or more, like 5.
Yeah. So that second significant, so you're right, so it has to be kind of, we'd be rounding on the second significant figure, so that one would tell us how to round the first significant figure. If one of these two are the same thing. So the first significant figure, for example, if we start with a 0, we have 0.3.
3, yeah, 0.3.
So the first significant figure is also the first decimal place.
Yes.
So they can be the same thing, but as we've seen from the example above, here we have 3 significant figures and 2 decimal places. This one here, we have 1 significant figure and 1 decimal place, because that first significant figure is in the first decimal place.
Yes.
Okay, awesome. So that's a little bit of a recap on rounding, and that's the kind of the difference between significant figures and decimal places. We also looked at question 5. So question 5 is quite an important example, where we said if we round our answer to a certain value, what's the range of values it could have been? So if I said 0.5 was rounded to 1 decimal place, what's the smallest number that we can round to give us 0.5? And what's the largest number that we can round to give us 0.5? So we're going to get 0.5 both cases.
Yes. So 0.5. Well, okay. I didn't. This wasn't the best one that I understood of this.
That's right.
Yeah.
Okay. Let's recap this one together in that case. So if we've rounded it to 1 decimal place, we had to have some more information about it, right?
Yes.
We had to have the digit that tells us how to round. So this one here would have a digit in the red box that told us whether to round it up or down.
Yes.
So if that digit was a 4 or less, we would have rounded it down.
Oh.
So for example, yeah?
So if the digit, so if the 5 or more, it would round up. So, and down, 4 less, it would round down.
Yes, perfect. So 0.54 would round down to 0.5. What would the decimal place before the 5 be?
0.
I think you said it.
11.0. Before the 5.
Yes.
0. 11.
So not 11, so if we put a 4 here, what happens with this number here? So with 0.45, what happens when we round it?
Oh, it would be 0.
So remember we're rounding to
0.50.
1. Yeah, perfect.
0.50.
0.5, because the 5 here tells us to round up. So when we have a 4 and we round it up, we get 0.5.
Yes.
Okay, so if we're looking at the range of values, either we round it down or we round it up. So those are our 2 options. Here we say the smallest value we have to round up to get 0.5, and the largest value we rounded down to get 0.5. Okay.
Yes.
So altogether, any number between these 2 will round to 0.5. So let's think of some examples. For example, 0.47. So 0.47 would round up to 0.4.
Because the 7 is 5 or more, it rounds up. So 0.50. 0.50.
Yes. So we can just leave it as 0.5. So once we round it to 1 decimal place, we don't need to keep including that. The zeros. So it's only before you round, or if you're rounding to, for example, so if you rounded, if I wanted to round 0.3 to 2 decimal places, looking at 0.3, we don't have 2 decimal places. So to be able to round it, we then just have to create our own second decimal place. So that's when we would use that second zero.
Let's say 0.37. It would be round to 0.4, not the 0. You don't have to add the 0 at the end. So 0.4.
Yes. Yeah. So if I was rounding 0.37 to 1 decimal place, then yeah, perfect. It would just be 0.4.
Yes. Okay.
Okay. So it's only when we round something to something that isn't there. Like in this example here, we rounded 0.3 to 2 decimal places, which of course we can't really do if that isn't a second decimal place. So that's when we actually needed to create that extra decimal place. Yeah. Good, and good example as well. So can you think of any other number that might, so any number in this range here that would round to 0.5? What other number?
0.48.
Yeah, 0.48, perfect. So again, 0.48 rounds up to 0.5. So what we kind of see here is that if we pick any number between 0.45 and 0.54, it will always round to 0.5.
Yes, okay.
So a good example is, so this is something that would be quite useful in this particular example. We we were looking at a running record. So we were looking at values that could round to 10.5.
Yes.
So this is a good example of, this is something that we might come across whenever we see rounded answers. We need to know that it's not just that answer, there are different possibilities for the actual answer itself. Okay, so is that all right? Did you have any other questions on rounding?
No, that's all I have for rounding.
Okay, so the next one is estimating. So if you just want to quickly recap, when we estimate, why do we estimate? Why is it useful for us to use estimation?
Okay, so if there was like a number that that you had to, so let's say estimate, like say someone gave us a question and you have to estimate like which one is the closest to like 300. If there was like 257 and 67, you would estimate that 257 is closer to 300.
Yeah, perfect. So for example, yeah, that's a really good example. So we have two answers and we know that by estimation, we know our answer needs to be around 300. So we can compare like the relative sizes of those two answers. Yeah, that's basically exactly it. Cool. So I think that one is probably all right. So we'll go on to powers and roots. So we didn't quite finish this topic. We got up to question 4 on here. I just wanted to recap the previous two questions. There's 3 questions, but the 2 and 3 are sort of very similar. So start with question 1. We were finding the correct power for each one.
Okay.
So to do that, we were working through the powers of these numbers here. So let's take the first, let's take the second example here. 81 equals 3 to the power of something. So we were just multiplying 3s and seeing how many we needed. So 3
times 4.
Yeah, perfect. So it was 4 3s multiplied together. So 3 times 3 gave us 9, then we got 27, and then we multiplied it again by 3 to give us 81. Okay, so in this box here, we would write the number 4. Because we were looking for how many, so when we're asking what's the correct power, we're saying how many times do we have to multiply it by itself, like we do here, to get our answer of 81.
Yes.
So in this case, we needed to multiply 3 to the power of 4 with 3 by itself 4 times.
Yes.
Okay.
The next.
Yeah, next one. So next one, we were looking at kind of combining estimation and powers. We had a range, so we know that 7 to the power of 5 was 16,000. So I'm just going to round these up. And 9 to the power of 5 was 59,000. And we were saying, let's look at 8 to the power of 5. So if we're looking for 8 to the power of 5, what we know is that it has to be between 7 to the power of 5 and 9 to the power of 5. Okay, because they grow at the same order. Okay, so that's everything from last time. So we're going to start a little bit of new stuff, finish off the estimation worksheet, then we're going to look at powers of 10, and then we're going to look at a review for everything so far.
Okay.